Hey everyone, welcome to another video. My name is Elric. I'm going to do a short series on optimization where sometimes I run into issues and it's too slow for what I needed to do. So yeah, these are going to be like mini series in this giant series. It's really hard to explain what I'm trying to envision. But I have 3 videos right now I just got done with my optimization, going over indexes and how I'm taking this thing that runs a minute and 29 seconds to build 3,500 objects. I got it down to 15 seconds. So that's the first 3 videos in this part or in this series. And then later down the line, when I run into other things that become problematic, I'll create another smaller series within this one, and I'll just keep the numbers incrementing. So overall, this is the optimization section of master data management, and you'll learn a lot about key lookups in the execution plan and scans and seeks and how to, familiarize yourself with them and make an efficient index structure. So thank you very much for watching, and I will see you soon. All right, so the first thing I can do, or I was trying to do, is for all my data sets, I was trying to rebuild views, all 5 views. So the base view and then the select, insert, update, and delete view. Now my main query returns, my bad. 726 data sets. So I'm trying to create over 3,500 views, and it's taking a minute and 29 seconds. But I think that's slow. I think we could improve that performance. So the first thing we want to do is basically attack this query slowly. We can use the execution plan to do that, but really, we can be more specific on what's going on. So when I'm trying to filter by the type ID, which is what the in statement will do, I get a scan on the primary key. So I have this other instance open, and basically the rule of thumb for non-clustered indexes is everything in the where include what's in the select. So in the where, it was the type ID, include the primary key, which is the dataset ID. So I can do type ID, include dataset ID. And for the storage options in my system, I want to make sure that all my indexes are on the index file group. So then I can go back to my query, run the execution plan again, and boom, I'm over in seek land. So same thing, then I just kind of extend it and use the estimated execution planner, and I see I got a scan on the dataset again. But this is probably because of my other items. Key lookups, a couple seeks in here, realm, type. So this is coming from this table value function. Now, like I said, whatever's in the where clause followed by what's in our select. So when we have the key name both in the select and the where, we want to actually index on it. And the practice for indexing is fewest unique values to most unique values. So there are less family IDs than key names, so the family ID will be the first in the list. What else do we have? Tenant ID on the type. So the type is a little different. Now there are 2 ways to do this. One of them is we can create 2 indexes, or we can be conservative about it. So assuredly, for the dataset type, I know that I need non-clustered index for the dataset type, where I'm filtering by the tenant and the key name. So tenant and the key name. And my family ID and the type, family ID is in a where clause, and the type ID is in a select statement, because the type's family will go backwards. Oh, I made a mistake there. Where's the family? There we go. So then we'll put this on the index. So we have the tenant ID and the family ID, because the family is being passed down to another table via the cross supply, and the key name's also being filtered on and returned. And this kind of helps us out, because if the key name is null, it'll focus on the top two, which is what we want. And then the dataset ID is, the type ID is just being returned. So I can build that. And then I can script as create and remove the tenant ID, remove the tenant. Oh, I messed up my naming here. Include type ID. Include type ID. Oh. So, because of our consistent pattern, we can actually replace type. Oh, we want to do it backwards. So family with class and type with family. And that'll basically get our next one, where the class ID is going to be filtered by the class table, and we want the key name and the family name, family ID back. And I'll just go back and show you what I'm talking about right here. Even though we have all three of these in the select statement, the class ID is actually being sent down farther. So it's becomes like almost an artificial where. So using those patterns, we can do that, execute it. So now we have one on our family. We want to take class and turn it into realm. We want to take family and turn it into class. Execute it. We want to turn class into realm. And then we'll take this. And actually, we're only filtering on the key name, but we are asking for the cluster ID back. So we can add that to the includes. So now if I go back to my code and run it, we get seeks across the board. Let's see what that scan turned into. Nope, it's a seek also. So sometimes you can run into like this giant cluster of like trying to figure out, well, this is in the where, this is in the select, but realistically, anything that's being returned but also being joined on or filtered by needs to go into that primary piece of the index. And then anything that's returned additional to what's being filtered on needs to go into the include. So then we start getting into things like this, where key lookup. And actually, I think this is a good piece or a good time to break, and I'll continue this video because I just kind of went over the basics of non-cluster indexes. So I will cut right here and then make another video about the key lookups and index seeks and how to remove those and what this means. So thank you very much for watching. Hope you enjoyed. Remember, like this video and YouTube will recommend it to users in our industry, and subscribe to support me. Have a good one, and I will see you next time.